Construct a truth table for the following statement and decide whether or not it is a tautology. Tautologies basically are going to be the fact that once I've constructed the entire truth table, the final column has to be all true. If they're all true, then we have a tautology. So we're going to start off with the fact that we have two components here. We have this first statement, P implies Q, and then we have the larger statement outside of that, that P implies Q implies not P. So now I need to construct a truth table concerning these if-then statements, and that's really what implies means. For this first one, P could be read as if P then Q. And the truth matter of P or Q really doesn't come into bear until we've actually gotten the table together and we talk about what each one of these is going to have as a value. So we'll start with P here and we'll have Q here. And then we'll start with the fact that P can be true, and if P is true, Q could be true. P could be true and Q could be false. P could be false and Q could be true. And then we could have the fact that P is false and Q is also false. Now what we want to do is we want to construct the if-then statement. And like I said, P with an arrow to Q can be read in two ways. If P, then Q, or I could simply write P implies Q. The only time that this statement is going to be false, this will be false when P is true and Q is false. So let's go ahead and put that together over here. We're going to have the statement P implies Q, or if P then Q. Notice that here it's true and true, therefore this will be true. Here it's true, P is true implies false, that would be false. Then we have false implies true, that would be true. And then false implies false, and that would be true also. Alright, now one of the things that we need to put in place that we haven't done yet is a not P, because that's the next part of this statement, not P. So if P is true, then not P is false. If P is true, then not P is false. If P is false, then not P is true. And if P is false, then not P is true. So now I've lined up my not P column. And now I can go ahead and start with the last part of the statement, which is going to be this. We start with P implies Q, and then we say that implies not P. So in order for this to happen, in order for this to be correct, we note that the P statement, if it's true, then the Q statement must be true in order for the whole thing to be true. If the P statement is false and the Q statement is true or false, then the whole thing will be true. So let's look at this. We start off with P implies Q. If that's true, and in this case it is, and then that implies not true, which is false, okay, is that a true statement? And no, that is false, because if this is true and that's false, we start here looking at this one. If this is true and this is false, then we have a false statement. If this is false, does that imply false? That is a true statement. This is true and it implies true, and that's a true statement. And this is true and it also implies true, so that's a true statement. And so that talks about the statements. Now, is this a tautology? In order to understand if this is going to be a tautology, all four of these Phew! Whew. Must be true. And since all four are not true, this is not a tautology. And that would simply be because of this entry right here.